Hey, Paul,
Hey, Rich.
what do you got here today?
Well, we got some AMCI integrated drive stepper motors.
Steppers. Again, I'm a servo guy, right? I spent a
Sure.
lot of time in the servo motion control world. Why would I use a stepper motor versus a servo motor?
So number one, you're going to look at a stepper because it's lower cost. You're going to use it a lot when you have less dynamic applications. Obviously, there's a lot of room for servos in the market where you need that type of dynamic motion. Stepper motors are great for presetting axes. So we might be turning a screw for a setup application on a machine, and then it's going to sit there for the whole length of that run, where a servo's dynamic capability is wasted just sitting still for 6 hours, 10 hours at a time. So a stepper makes a lot of sense for presetting applications.
Okay, so if I have a varying load, I got a situation where the load is constantly changing. Is that a stepper or is that a servo type of situation?
I would think that's more of a servo application.
That's more of a servo,
Yep.
okay.
Yep.
Whereas if I need to just get to a position and stay there,
Yep.
that makes sense for steppers.
Full torque at zero speed is what we like to say about a stepper. So it's got a lot of power just sitting still, and it doesn't need to be moving back and forth dynamically.
Okay. I think I saw a speed torque curve recently where it looks like on a stepper, that torque falls off very quickly as you go higher in speed.
Absolutely. So one of the things AMCI does is they allow higher voltage to help combat that. So with these steppers, we could say 24 volts or 48 volts. You have a better speed torque curve at 48 volts than you do at 24 volts. But regardless, really pretty much once you get above 600 RPM, you really should be going servo versus stepper.
Okay.
Because you'll see the torque drop off significantly.
Okay. I've always thought of steppers as an open loop device. Can you get these things with encoder feedback and
Right.
position?
Yep, absolutely. So it is still considered an open loop device. However, you do have the position feedback. AMCI will sell these motors with no encoder, an incremental encoder, or an absolute encoder.
Okay, so I can get that position feedback. If I got a PLC that wants to kind of close a position loop, we can get that feedback.
Absolutely. It's got a 2048 pulse per rev absolute encoder built into it.
Okay.
Yep.
One of the things I struggle with in the servo motor world is different manufacturers have different sizes, different mountings, things like that. Is there any standardization when it comes to steppers with regards to that sizing?
Absolutely. So AMCI has three different sizes. NEMA 17, the smallest stepper we have. We have three different NEMA 23 motors, and then three different sizes in NEMA 34. So each one is a NEMA standard.
Okay, so when we talk about NEMA standard, we're talking about mounting dimensions, shaft
Yep,
size,
absolutely.
all that good stuff.
Yep.
All right. What about communications? Can we talk to these guys?
Absolutely. So it does have an integrated controller and drive. So basically you need to give it 24 or 48 volts DC, and then a field bus. So it could be Profinet to talk to our Siemens PLCs. We also have Ethernet IP, Modbus TCP, and EtherCAT are also options for field buses.
Interesting. So you just said controller, drive, and motor all in one.
Yep.
So I don't have to have a separate amplifier or drive card that interfaces with the stepper. Right. It's all in one device.
All in one. You have a nice little switch for your Profinet, so you could bring connection right from the PLC to the drive, and you're issuing all your motion commands in the PLC, and then the drive and the motor are doing what you're asking it to do.
All right, great. Are steppers the only thing that AMCI offers from a
Nope.
motor perspective?
So AMCI has been making the steppers for quite a long time, and then everyone, of course, wants bigger, better, more. And so we've now come out with an integrated drive servo motor. It's a DC servo. Will work on 24, 48, or 72 volts DC. It's a 3,000 RPM servo, so where the steppers you're really looking in the 600 RPM range. The servo will do 3,000 RPM, and this one is about 1.2 Newton meters of torque.
Wow. So again, this device is all that I need besides 24, 48, 72 volts DC,
Yep.
a communications bus, and this is it.
It's your axis of motion, nothing in the cabinet.
Very neat. Nice and compact. Good looking solution. All right. Thanks a lot, Paul.
Thank you, Rich.